Okay, for tomorrow, for homework tonight, hopefully you got some of these problems done in class. I'm going to have you do them in your new packet, and then I'm going to have them do in your composition notebook again and write a sentence for each one. So all of these are Pythagorean theorem problems. I am going to add the right angles to all of these because I want you to make sure it's a right triangle before you start using the Pythagorean theorem. So those are all my right angles. Once I have right angles in there, I know they're right triangles, so I could go ahead and start to use a squared plus b squared equals c squared. The most important thing of all is knowing that the two numbers on either side of that angle are the legs. These always go together. These, either side of the triangle's right angle, these will always go together. Here's my right angle. This one and this unknown go together. Here's the right angle. That 3 and that unknown go together. Right here, that 4 and this unknown go together. Either side of that right, this last one, right angle, both these go together. So just make sure you always have the legs on one side of this equation and the hypotenuse on the other. If you don't like it with that c squared on the right side, you could always flip it around, do the associative property of addition. So I flip that around, I get 9 plus 16. Remember, 3 times 3 is 9. 4 times 4 is 16. That gives me 9 plus 16, which is 25. Square root both sides, and hopefully you see that 25 is a perfect root number, and I just get c equals 5. Try to memorize that triangle. 3, 4, 5. 6, 8, 10 is another. All right, for this unknown c squared, I'm already writing it on the left side. Maybe that will be better for you. Equals these two together, 12 squared plus 5 squared. Gives me 12 times 12, which is 144. 5 times 5 is 25. When I add those up, I get 169. When I square root both sides, the square root of 169 is 13. That is another perfect root we expect you to memorize. Alright, next one. These are the legs. So that 1 and this unknown, I'm going to use b because again these legs are either a or b. So 1 squared plus that b squared equals the longest side squared. So 1 plus b squared equals 16. Take away 1 on both sides. Whenever you have an unknown as one of the legs, you will always do an inverse operation like this before you square root both sides. If both legs are given, you just plug them in and add them up and square root right away. All right, 4. Again, I have 3 a leg and I have an unknown as another leg, so these go together. I'm going to use a instead. Here by mistake, I put the hypotenuse in a leg and I realize that now, so I'm going to erase that. So it will be 3 and this unknown a squared. So a squared plus 3 squared equals that root 10 squared. Remember, when you square a whole number, that's 3 times 3. But when you square something square rooted, those cancel away and just give you 10. Because remember, root 10 squared is root 10 times root 10, which is square root of 100, which is the whole number 10. So now on this one, I take away 9 on both sides. I will fix that, so that is a 9. And I get a squared equals 1. Know that the square root of 1 is 1. 1 times 1 is 1. Alright, next one. These are the two legs. So 4 squared plus this unknown length squared equals root 17 squared. Remember, when you square 4, 4 times 4 is 16, but when you square something square rooted, these cancel away and just leave you the whole number 17 right there. Take away 16 on both sides, gives me a squared equals 1. And then when I square root, I see that a is 1. Technically, a is plus minus 1, but we only use the positive value to represent a length. Alright, 6. These are the two legs. 2 squared plus, I'm going to use b this time. So these two together equal root 13 squared. That gives me b squared plus 4 equals root 13 squared, which is 13. Take away 4 gives me b squared equals 9. And hopefully you realize that's a perfect root. Square root both sides. And you get b equals plus minus 3. But we're just going to use 3. So b equals 3. Alright, next page. The next page problems has you count boxes and then use the Pythagorean theorem. So these are all right triangles. I can see this is a 90-degree angle on all of them. So I count. When you're counting, be careful. That first one, that's not 1. From here to the first spot is 1. So people by mistake will think this is 1, 2, 3, 4, 5, 6. They'll think it's 8 boxes long, but it's not. From here to here is 1. So this length is 1, 2, 3, 4, 5, 6, 7. 7 boxes long. The top part is 1, 2, 3, 4 boxes long. Those are on either side of my right angle. Those are the legs. Those go together. So 4 squared plus that 7 squared equals this unknown c squared. I could use c or I could use x. C squared equals 4 squared plus 7 squared, which is 16 plus 49. That gives me the square root of 65. And that has no perfect root in it, so I am going to leave that alone. Alright, number 2. I'm going to count boxes. 1, 2, 3, 4, 5 boxes long. Not 6, 5. 2, 3, 4, 5. 7 boxes long right there. That gives me the unknown, because again, these are on either side of the right angle. Those are the legs. So c squared equals 5 squared plus 7 squared is 25 plus 49. And that gives me a number that cannot be square rooted, I believe. Doesn't have a perfect root in it, so I leave that alone. It's going to be 74. Square root both sides. The square root and that 2 cancel away and just leave me c. And that answer is root 74, which I leave there because I cannot reduce that or simplify that. Alright, 3. 1, 2, 3, 4, 5, 6, 7, 8 boxes long. 2 boxes tall. Those are my legs. The unknown hypotenuse is 2 squared plus 8 squared. Gives me c squared equals 4 plus 64. C squared equals 70. Square root both sides. And I get c equals root 70. Alright, number 4. This one, I count boxes again. My bottom is 1, 2, 3. I'm going to do this in 2 ways. I'm going to do this by looking at only this little half of my triangle, and then I'm going to look at the whole triangle. So if I look at just that one little part, this is 2 boxes, this is 2 boxes long. That is a little right triangle. So if I use the Pythagorean theorem with those 2's as legs, that will give me what x is. And since these are equal, this x will of course equal what that is right there. So this setup gives me x squared equals 2 squared plus 2 squared. That is x squared equals 4 plus 4, which is x squared equals 8. Square root both sides. That gives me one that can be broken down. Root 8 is made up of 4 times 2. Break that apart into root 4 times root 2, and then square root the 4 to get your 2. Bring that down. I did skip a step right here where I should have wrote square root of 4 times 2, but that's okay. Split it apart. 2 root 2. The second way is looking at the whole triangle. So if I look at the whole triangle instead, I will use the bottom as 1, 2, 3, 4 boxes all the way, and then this is an x and this is another x. So I'm going to use these 2 legs as x's. So that would be x squared plus another x squared equals a hypotenuse squared. These combine to give me 2 of those x squareds equals 4 squared. Before I square root, the opposite of timesing by 2 is dividing by 2, and that gives me x squared equals 8. And then again, when I reduce x squared, or if I simplify the square root of 8, I will get the same answer. I will get root 4 times root 2, which simplifies into 2 root 2. Remember, when you square root that 4, that square root symbol goes away forever. Good luck. I'm here every day at lunch or break if you need help. Please come in.